Okay, so what we're looking at is question 3 now. And let's have a look. We've got the table. There's a table here. Oops. Oh, there we go. It shows the yearly average traffic congestion levels in two cities, Melbourne, Sydney, during the period of from 2008 to 16. There's also a time series plot. That would be this part here. Okay. And the one for Melbourne is incomplete. So the first part of the question is use the data in table 3 to complete the time series plot for Melbourne. So we've got to make sure we're looking at the right numbers. So Melbourne is basically our second line. So it's here. And it's from 2014 to 16. So these are the numbers. Let's actually go up because we're going to need to relate to them. Okay, those are the numbers we need. So for 2014, I need to go up to 28. So 26, 27, 28. 2015, I've got to go up, so that'll be 29. Oops. That'll be 29. And then you're going to go to 33. So 31, 2, 3. Okay. So it's basically going to look like that. Okay. So that's part A done. So the least squares line is used to model the trend. So we've got a least squares line there. So we've got a year here that we use. And then we're going to get two numbers and we plot them onto. So basically it's, we want to, this is a trend line we've generated, but now we've got to put that onto the time series plot. So basically you need 2 points. Okay. I'm going to pick 2008 just because that's the first year and 2016 because that's the second year. So let's quickly put that in the calculator and I'm going to go minus, oops, wrong thing. Minus, no, don't like it when it does that. Yeah, there we go. Put that in. 2280 plus 1.15 times, and this is where we're going to go 2008 as our first one. Okay, we get 29.2. Then we're just going to change this to 2016. Okay, so our numbers essentially are going to be here. Oops. So if you remember, this is our X value and this is our Y. Our Y's for the 2008 is 29.2 and for 2016 it's 38.4. Okay. All right. So we need to go plot those now. So 2008, you're going to go 29.2. So 29.2. Remember this is for Sydney. 29. So 29.2 is roughly, say roughly there. Yeah. It's a bit hard to do on the computer than you would do on a piece of paper. So roughly there. And 2016 we got 38.4. So that's about there. Okay. Again, like that. And then you'd get your ruler, which I don't have with me. I could use something, but just for the sake of this, I'm going to say something like that. You would actually draw it better than that, clearly. Okay, you get a ruler and do it. So make sure you've got a ruler. Okay, so that's your trend line. So you put your draw least squares line on there, and that would be your answer for that. So that's what we're looking for on there. All right, use equation to determine the average rate of increase. Now, in this one, what was found was that the 64% got this wrong. So 64% got this question wrong. Oops. Okay, that's a lot. Now, the way you avoid, and the reason they got it wrong, okay, is to do with this. Okay, they didn't make the connection that when we look for the average rate of increase, we're looking for the gradient, okay, or otherwise known as the slope. Those are the two key points you need to be conscious of. Average rate of increase, that's what it's after. It's basically the slope. Okay, so and this is a really easy question, because when you look at the average rate of increase and you look at the equation, this is your slope. This here goes there. So all you need to do is 1.15 per year. So that's the average rate of increase, 1.15 for every year. That's what you have to do for that question. But 64% got it wrong. Don't be in that 64% if you get a similar question. Okay, use the least squares line to predict when the percentage congestion level in Sydney will be 43%. Okay, so what we need to do, we need to look at, so we're basically the when is which year. Okay, now remember from our equation, so let's put congest, okay, and let's write the formula out for a moment. 28.0 plus 1.15 times a year. Okay, now we actually want that bit. Okay, so that's what we're after. So what can we use? We can use good old solve. So I'm going to replace that with an x. So my x, so x equals year, just because it's going to be easy in the calculator. I'll literally put a bracket here. I'm going to have solve on my calculator, and then I'm going to put a comma x, close the bracket, and then I'm going to solve it. I'm going to get x equals, so let's put that in. So I'm going to steal this because I'm going to use part of it. Okay, so I'm over on the calculator now. All right, so I'm going to go, what was it? It was congestion was, and I replaced the congestion here. So it says the congestion will be 43. So this is going to be 43 here. I'm going to have solve. So this is where I go up to menu, algebra, solve. To be honest, I sometimes just type it out because it's sometimes easier. And I'm going to go 43 equals, okay. I'm going to come back to here and I'm going to delete that because that's the one I'm after. I'm going to go x because that's the variable I want to find, comma, x, closes the brackets, press enter, and the answer is 220. So I put 220 here. Okay. All right. Let's go on to the next question, the next part of the question. All right. So now it's talking about Melbourne. All right. So when a least squares line is used to model the trend of data for Melbourne, the intercept line is approximately this value here. It just says around four significant figures now. Remember, significant figures are important in keeping in mind what you're doing. If I've got 4 significant figures, I'm after these first 4 here. Okay, so if I wrote 1514, I would still get it wrong. And you've got to think about what's next to the 4 to understand why. Okay, and that is because you need to round up, basically. That part there, because you've got a 7 there, that should now be minus 1,515. Okay. So use a table, use a data in table 4 to determine the equation of the least square to regression line. Okay. And round both figures to 4 significant figures. Okay. All right. So we can, to be honest, we could actually put that already in there. That's going to be minus 1515. But let's actually check that. So over in the calculator now, look what I prepared earlier, just because it was going to take too long to type that in on the video. So let's now go Control I. That'll bring up this. We want to go Data and Stats. We need to go click Add Variable, and I'm going to make that year for here. I'm going to make this one Melbourne. Okay, that looks like the data we've got so far. And now we want to analyze. No, we want to, sorry. It's been a little while since I've done this one. Sorry about that. It was analyze, and for some reason I completely missed it on this screen. Don't know why. Regression. And we want to go a plus bx, okay? Because that's the formulation we use in VCE further maths. So click on there, and we can bring an equation up so we can see it. So again, that minus 1515 still stays. Now, in this case, so I've got, after that, I've got 0.766. Now, it goes 66 forever. And the reason it actually doesn't there, because it rounds up. So I want 4 significant figures. I don't count the 0 there. But so therefore, I would have had a 6 next to this one. So I've got 3 already. I need a 4th one. So that means I've got to put that one to 7. So it'd be 0.7667. Okay. All right. So let's go to the next question. Next part of the question. Okay. So let's have a look. So it's basically, oops, sorry, wrong spot. And what we're looking at in this question is, since 2008, the equations for these for least squares lines have predicted that the future traffic congestion levels in Sydney will always exceed those levels in Melbourne. Explain why, quoting the values of appropriate stats. This one, when it says this, you need to use the numbers that you've been given. If you do not use the numbers you've been given, you won't get the marks. Okay? So, in this case, it's a two-part. So you've got to acknowledge that there's a reason you've got to acknowledge the starting value. So the higher starting value for, I should put that in capitals. And that was 29.1. Sorry, not 21.1, 29.2. And where we get the 29.2 from is this part up here. Because remember, that's our starting value. Okay. And if we do this same thing with the Melbourne, so if I go minus 1515 plus 0.7667 times 2008, that'll give me, so here I'm after the 24, oh, oops, sorry, that was, did not see that happening just there. I want to get rid of, I've just got to start using the minus sign, not the actual subtract sign. My bad on that one. 24.5. Okay, so 29.2 is bigger than 24.5. Now, that in itself is not going to explain it. It just means that Sydney starts higher. But because Sydney has an average, but Sydney also has an average rate of increase of 1.1 0.15. And this is bigger than the Melbourne, which is 0.77. That means Melbourne's never going to catch up. They're starting lower and their rate of increase is also less. So it's like saying if I have a graph like that, Sydney starting here, Melbourne starting here, just place, but Sydney's always going to be like that, Melbourne's going to be like that. That's basically what we're saying. You just got to maybe write a bit, and I've written it there. But that's what you're looking for in a question like that. Okay? And that's this question done.